Hello everyone, my name is Sheikh Mohammad Fawaz. I'm studying in Sri Venkateshwara College of Engineering. I'm studying in 7th semester in CSE AI. So today we'll be discussing a topic in NoSQL. Today my topic is impedance mismatch. So in NoSQL, databases have gained a lot of popularity for their flexibility and scalability. However, they have certain challenges, that is impedance mismatch, a conflict between the data structures used by the application and the database. This presentation explores the nature of impedance mismatch, its implications, and strategies to manage it. So first, let's understand what is impedance mismatch. So impedance mismatch is the difference between how the data is represented in the application as well as in the database. So the data structure impedance mismatch occurs when the data structure used by an application, often the objects or graphs, don't align directly with data models of the database, which are often tables or documents. Programming languages, the mismatch extends to the programming languages like object-oriented languages like Java, often refer data as complex objects, while NoSQL databases store data as documents or key value pairs. Okay, so we have different types of NoSQL databases. So first is key value stores, then we have document databases, then graph databases. uh, so let's understand what is key value stores. So these databases store data as a simple key value pair, offer offering high performance and scalability. So the key refers to the unique identifier and the value is the data which we are storing. So yeah, the values can be nested values, and it can be it is very easy to retrieve this value based on the key. Then we have the document B database. They store data like JSON structures or documents, providing flexible schema and easy data access. For example, MongoDB, where we can store the database data as a collection or objects. Then we have the graph database. So these graph database are designed to represent and query relationship between entities. These databases excel in managing complex networks. So when we have multiple relations, these are similar to the node graphs, how we connect each entity with another entity with having multiple relations. These relations can be bidirectional, unidirectional. So we use these type of NoSQL databases. Schema flexibility in NoSQL. So first thing is NoSQL is schema less. So NoSQL database often allow this for schema flexibility, meaning that the structure of data can evolve over time without requiring predefined schema. Dynamic models. So this flexibility is a key benefit, enabling rapid development and adaptation of evolving value data and requirements. Then we also have data evolution. So NoSQL databases can handle changes for data structures without requiring significant schema changes or data migrations. Yeah. Now let's understand impedance mismatch at a higher level. So first is the data model discrepancies. So the data model used by the application and the databases may have different structures, leading to translation issues. Then the type conversion, converting data between different types such as objects to JSON documents can introduce errors and performance overload. And also querying languages, the querying languages used for applications and NoSQL databases may differ, requiring complex data retrieval and manipulation. Now we also have performance implications. So impedance mismatch and performance impact. Data translation has its performance impact, increasing processing time and resource consumption. Query optimization, less efficient query execution due to the data model differences. Then we have data consistency, potential for inconsistencies when mapping data between different data structures. So all these are performance implications. Now we have the handling impedance mismatch. So we have the ORM libraries, that is object relational mappers. So provide an abstract layer to map objects to the database structures, simplifying data access. Data mapping, explicitly defining data mapping between application objects and database object and documents, can improve data consistency. Data transformation is transforming data into a format compatible with both application and the database. So therefore, reducing the impedance mismatch. Database selection, also it is very important to select the right database structure for the use case. So these are the handling impedance mismatch. Object document mapping. So you can see here, object is being serialized into documentation. So here the deserialization happens. So first thing is that the object representation, data is represented as objects in applications, often with complex relationship with and nested structures. A serialization, objects are converted into a serializable format such as JSON for storage in the NoSQL database. Document storage, serialized data is stored as document in the NoSQL database, preserving the structure and relationship of the original objects. Deserialization, when retrieving data from the database, documents are deserialized back into objects for use by the application. So we have the best practices for NoSQL design. One is data modeling, schema flexibility, data consistency, performance optimizations. So in data modeling, designing a data model that aligns application with application requirements and minimizes the complex data transformation. Embrace in the schema flexibility, we have the schema flexibility of NoSQL database to accommodate future changes and avoid rigid data structures. So also we have the data consistency, where the data is consistent among the application and the database layer, and performance optimization for the querying languages and the retrieval mechanism. So from this we have key takeaways are: impedance mismatch is a common challenge in NoSQL database development. Understanding its cause and implication is crucial for building a robust and performant application. By applying best and practices, utilizing appropriate tools and techniques, and selecting the right database structures. I hope you have understood impedance mismatch in this video. Thank you.